Okay. All right, so today we're going to talk about the AmpGen language and its use in the DecayLanguage package. So AmpGen is this tool that was written to do fitting and generation of multi-body particle decays. And the way that it works is that it reads in this custom domain-specific language that's in this nice, concise 100 or 200 line file. And then it produces the source code for, it's almost C, it's got a tiny bit of C++ in it that you can then compile and use. So you just compile it into a shared object library and use this wherever you would, you need either this simulated or if you want to do fitting. And because this is very simple, straightforward code that it produces, it's easy for it to support SIMD. The latest versions have SIMD support. There's a variety of different ways that you can use these output files. So the AmpGen syntax itself looks like this. First you have the event type, which tells you what event you're looking at. And then there's some other global options that look something like this. And then you'll have a series of amplitudes. So here you see the amplitude value. You can tell it to be fixed or floating if you're doing a fit. You can give it a real and imaginary value. And give it some extra fitter options for how large you want to move it around. Then you have this this thing on the left, which is the decay line that you're looking at. So in this particular case, you'll see, like in the example, you have a K star here, and this you first describe the particle in square brackets, which you don't see here. You can give it different types of amplitudes, and then you can pick a model that way. And then in curly brackets you have the decay products, and you can nest this. So you'll see the one above actually has D0 decaying to the K star, which then decays itself into a K plus and a pi minus. So you can also display the decay or specify decay in multiple steps. So down here you'll see the a decay that's specified there at the top, and then the down there decays two different ways. The decay language is a package that was written in Python that also has the ability to read AmpGen, this AmpGen DSL, but this time it reads it and produces goofit C++ code. So instead of describing the exact decay and expanding out that into just simple dependency-free C++, it's actually specifying goofit models, line shapes, and things. So later dec file parsing was added to this package, and currently the original AmpGen reader has sort of fallen into disrepair. It's been disabled from the tests, but that could be recovered quite easily, I believe. So this is what the input file that we're looking at looks like. This is a K3 pi decay, and you have some constants. You can skip through and you can see some of the decay lines, and then finally these you can specify various free floating parameters as well. So when it produces the C++ file, it actually gives you a nice heading which tells you what it understood about the decay. So it's describing there the decay lines that it detected, and these are sorted and specified by what the polarizations are. Here you have the different types of particles that it detected, and finally it lists all of the different decay lines and spin configurations that it discovered as well. And then the code looks like this. You've got these vectors of line shapes and spin factors and a vector of amplitudes, and it's going to go through and it's going to fill these in the rest of the file. And then you've got your constants, your floating variables, just as you saw, but just transformed here. And sometimes these can even be more complicated, like this is 5 values that are being stored together. And this is what an actual line looks like. So this is the first one, and you see that it's specifying the spin factors It's loading in the line factors, and then it's combining those into a new amplitude, and it's pushing that into the list of amplitudes. So plans are for this. We'd really like to restore the operation for this. There have been various changes in particle, which is a dependency. And AmpGen uses the 2008 PDG data file, which was removed from active particle, but hopefully we can either restore that or update AmpGen itself to use a newer data file. And then re-enable the tests and run on several different models, not just this one. Also, there's no reason that this can't produce, say, GoofIt Python code to configure GoofIt from its Python interface. The way that it was designed, there's a model decay and then an amplitude chain. And GoofIt chain is just a specialization of amplitude chain. But you could have any other specializations you wanted that produced any other framework code you wanted. PyGoofIt would, of course, be really easy to write. And if we have another framework that has these line shapes and spin factors, you could teach it how to produce that as well. All right, and that's the idea behind these two packages. All right, thanks.